Hey everyone, welcome to the VMware Cloud Networking Academy presented by 27 Virtual. In this session, we're going to cover container networking with NSX-T. Your presenter today is Rodney McIntosh, NSX-T vExpert. Enjoy the presentation.
Welcome everyone. We start today with a conversation about enabling container networking essentially with NSX-T. Right? We will focus our conversation around vSphere with Kubernetes. But before we even get into that, I'd like to start with a quick level set. So our agenda again is about vSphere with Kubernetes, right? And then we talk about the value, of course, that NSX-T brings. What does NSX-T deliver when it comes to container networking, and how does it do it, right? But again, before we get into that, I'd like to start with a quick level set. Now, in starting with my level set, I opened the conversation about Kubernetes, right? Though we're talking containers, the assumption is we've all heard about containers, and maybe some of us are working on containers, or at the very least, most of us have gone and done the little Google search, our best friend, and asked Google, hey, Google, what's a container? So I don't start there, but by all means, if you have any questions about containers, let's have them and we'll make sure to field them. So, question that's raised about Kubernetes is, what is Kubernetes? What is this thing? And what does it even stand for? Right? So Kubernetes is derived from a Greek word meaning helmsman or pilot, right? And it's basically an orchestrator. Kubernetes has been around for the last 5 years or so, since 2015 when the 1.0 release came about. Since then, it's gone through 18 releases. That means we're doing on average about 4 releases, right, per year. That's pretty fast when you think about it, how the platform is evolving. But the point remains, all that aside, what is it and what does it do? Well, it's all about container orchestration. Well, what exactly do we mean? Well, let's say I went in and as a developer, I needed to deliver this container, right? This container is going to provide some rating service for my application. Let's assume my application is some streaming service, the likes of Netflix. And I want my audience to be able to view a movie and provide some rating and feedback about that movie, right? So we write this application, right, in a container. Now that I've done this, this container needs to reside somewhere or run somewhere, and generally containers will run on some container host. That host can be a bare metal server, or it can be a VM. Now, we propose that you use VMs, and if you think through it, you realize that using VMs for containers makes perfect sense. But again, they can be bare metal. For the purpose of a conversation though, let's regulate them to virtual machines, right? So I'm a developer, I've developed my container, and I deployed this container. Nice. Question is, over time, what are my concerns? My concerns now have to do with lifecycle management of that container, right? I need to basically update it. I need to, as I have more users using this application, the streaming application, and in turn using this rating component of the application, right? It gets more and more popular. So the end result is this one host may not provide sufficient resources to meet the demands of the users when they're going to try to rate a movie. If they try to rate a movie and it's taking too long, well, they've got better things to do and they go elsewhere. And that doesn't provide the service that I intended. So I may need, at this point, to have this container deployed on another host, and maybe even another host. But now what happens is, as a developer, I'm fully involved, not just with the coding of this service, but the lifecycle management of it, right? Kubernetes says, you know what, Mr. Developer, why don't you focus on developing your application? So go ahead and build your container. No problem. Go ahead, as part of the build of your container, go ahead and specify your YAML file. And in that YAML file, you can say things like how many instances of this container you want, or this pod you want, because we use the notion of pod. So let's say I said 2. Now let's assume I had 4 nodes that could run this container. Kubernetes at this point takes over. Number 1, it's focused on deployment. So it takes this pod and it deploys it. But it sees that what we want is to have always 2 instances of this. So it deploys a second one. I have 2 running. Everything is fine and nice. Let's assume this host dies, VM, physical server, whatever it dies. We still have 2 instances. No, Kubernetes sees that. And what does it do? It spins up an instance on another node. Let's say over time, I realize as the developer that 2 isn't enough, right? All I do is I go and I change my YAML to 3, make that update, Kubernetes sees it, and it deploys yet another one. Something else also provides is the ability for me to define services, because if you think about this, if I'm doing this, I need a load balancer, right? So I need to define a load balancer service that will basically allow for that ingress. So it allows me to define a load balancer service. This is not to say Kubernetes provides the service itself. It allows me to define it. So in the case of something like NSX, it can go up to NSX or whatever this load balancer is and say, go ahead and create the VIP for me and assign it this information to them. Okay? But the point remains, it's all about application deployment and lifecycle management. That's what it's about. If we are talking about moving into a world of rapid application development, then we need rapid application deployment and management to make that a reality. And that's where Kubernetes comes in. So let's talk about the components and then also map out some terms that we throw around when we start talking Kubernetes, so that again, we can have that level set, because as we move into the conversation with vSphere with Kubernetes, you will see some of these terms come up again and again. So I want to make sure we've got this covered. Now, when you set up a Kubernetes environment, you're going to have what we call nodes. These nodes, they will run your containers, okay? Your nodes fall in one of 2 categories. The primary one is your master node, which is this guy you see over here. The master node has the API server. As you can see, this is where you will issue commands against. It also has a dashboard, so you can see what's going on in your environment. It has a scheduler. If you remember when I talked about having 3 replicate sets or 2 replicate sets, the scheduler maintains that, right? It sees that this is what we want, and it ensures that that is realized and maintained, right? So that's essentially my control plane, if you will, for Kubernetes. Then I'm going to have 1 or more additional nodes that we call the worker nodes. This is where my containers will run. In the worker nodes, there's a number of things, but the one thing I want to point out is this thing over here called kubelet. The kubelet, as you can see, receives instructions from the API server. So in essence, when I deploy a pod, right, and the master node elects 2 or 3 nodes to deploy that pod, is communicating with the kubelet. Kubelet is like the agent, the Kubernetes agent running in that pod to carry out the instructions given by the master. For those of you that are more vSphere inclined, it's kind of like saying, I've got my vCenter server, that's the master, and I have my ESXi host, and the ESXi hosts are running the VPXA agent to carry out instructions from vCenter. So I've turned around containers, 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 and containers is what we create. But from Kubernetes perspective, it's about deployment. What Kubernetes deploys is something called a pod. A unit of deployment is known as a pod. A pod can have 1 container in it, or it could have multiple containers in it. So going back to my example of this rating application, my rating application maybe is exposed through some API over port 80, or maybe it's even a web. It's a web application itself. So it's running through Nginx. But then I might decide to add some other containers that allow me to expose port 22 for management, so that I can SSH into that container to troubleshoot it if I ever needed to, and maybe even another container for it to ship its logs to, because keep in mind, containers by default are stateless, right? So if this was my primary container providing the service that I need, if that container goes down and I weren't shipping the logs elsewhere, then that means I have no means of troubleshooting to see what the source of the problem was, right? So again, pod, unit of deployment. A pod can have one container or it can have multiple containers. Think of it kind of like a vApp, again, for those of us that are vSphere inclined. I can create a vApp and put one virtual machine in it, or I can put multiple virtual machines in it. But what I deploy nonetheless, from Kubernetes standpoint, is a pod. All right. Another concept we want to touch on is that of a namespace. We talked about the fact that you can have a cluster, and the cluster has a master and multiple nodes. Now, what if I wanted to divide that cluster into tenancies, right? These tenancies may be to facilitate different business units or maybe even different applications. Why would I want to do that? Because for a given application or for a given business unit, I want to ensure that only the respective DevOps teams can deploy pods in that namespace versus another namespace that's relegated or dedicated to another team. And I can also assign resources to them, right, to ensure that there's isolation between them. But that is essentially what namespaces are. Okay, so we can assign quotas, we can assign rollback access control, right? But it's a way of implementing multi-tenancy for containers. Now, there's some quibble back and forth about whether we use namespaces or whether we just create multiple clusters, and I'm not even going to get into that. The point is, if I have a single cluster and I want to subdivide that cluster, we create namespaces to subdivide said cluster. All this said, it's important to note that NSX's role in all of this is to provide networking and security for all things beyond just virtual machines. And now we're talking containers, so containers nonetheless. NSX, as of version 1, I believe it was 1.1 or so, we introduced the NSX Container Plugin, or NCP. It's a pluggable or adaptable framework that allows you to basically install and configure the module to provide support for the given container orchestration system. So if I was using standard Kubernetes, I put in the Kubernetes adapter. If I was doing PKS, I put in that. If I'm doing OpenShift, I put in that. But the end result is these plugins allows NSX to essentially listen to the master. And if the master says, okay, we're going to go create a new namespace, NSX knows every namespace relies on me for a number of things, starting with a segment. Every namespace has an isolated segment because namespaces need to be isolated. So it knows I need to go create a segment, so on and so forth. And we'll talk about this in more detail as we go along, right? But again, the framework still remains the same, and we can still leverage this framework for other container orchestration systems. What we want to talk about and focus our attention on, however, is what we've introduced with vSphere 7 and NSX-T 3.0, right? Something we call vSphere with Kubernetes, okay? So with vSphere with Kubernetes, we essentially end up having an environment that's built using vSphere 7 alongside NSX-T 3.0. Within this environment, we provide these new capabilities that we didn't have before that starts to deliver services for my BI admin alongside my DevOps team simultaneously. Now, what exactly do we mean by that? Well, let's consider this. I'm your standard BI admin, right? I'm using vCenter, I'm using API, and I'm doing my standard things of building clusters, managing virtual machines, managing resource pools. I do all of that. I know it, this is good. All of a sudden, drops on my lap 2 months ago, we're gonna now start doing containers and we need to do them in virtual machines. I don't know anything about containers. Don't worry about it. The containers are running in the virtual machine. It's just the virtual machine you have to manage. Okay, so we attempt to do that, right? Now it's a VM. That VM could have 10 containers. It could have 100 containers or more. But the point is, as we deploy more containers in the VM, as you can imagine, the VM needs more resources. So as an admin who doesn't have visibility into that, how do I really ensure that I'm delivering the service and the service level for these applications? I can't. Again, I know absolutely nothing about containers, right? All I'm told is it's a VM, just manage the VM like you would ordinary VMs, but it's not an ordinary VM, right? And then if we start to get into this notion of having multiple Kubernetes clusters, what does that then mean? If some team decides we need to have our own cluster, this now means we have to go through this whole process of deploying a new cluster, at which point we start saying, well, let's bring in Docker Swarm, or let's bring in PKS, or let's bring in some other system that orchestrates the deployment of these clusters. And before you know it, what we end up with is a dedicated environment just for containers. Because now my vSphere admin is totally out of the loop. He has no idea when we need a cluster, there's something else and someone else that's doing it. And when we need to increase resources, I don't even know when. I have no visibility into it. I have no control. I have no way of saying this DevOps team has access to these set of machines. Is very difficult. So because of that, what we start to find organizations do is they create a dedicated silo for their modern apps. We're saying, listen, we are providing you all of the tools for building a modern infrastructure with vSphere 7, NSX-T 3.0, VCF, vSAN, and all of these tools. If the infrastructure is modern, that infrastructure needs to be able to handle your existing workloads as they are, but also handle your modern applications, allowing your DevOps team to use that same cluster to deploy not just VMs, but also pods, giving you, the VI admin, the ability to carve out and define policies as to what the DevOps team can do, and giving you visibility, not into just virtual machines, but visibility into the containers, the pods that are being deployed, and see what they're actually using and doing. Okay, so this is what this concept is based on. That said, how do we make all of this a realization? How do we make all of this possible, right? We start with a standard SDDC, a standard environment running vSphere, NSX, maybe vSAN, right? And whatever tools we have within our SDDC. Within that SDDC, we would have one or more vSphere clusters. Here we've illustrated 2 vSphere clusters, right? Now, these vSphere clusters, one or more of them, can now be enabled with this capability to run containers natively. When that happens, that cluster becomes a supervisor cluster. Otherwise, it's just a standard vSphere cluster. But the moment I enable the capability on that cluster or those clusters to run containers natively and essentially deploy the control plane on those hypervisors in that cluster is now known as a dual purpose cluster that can run virtual machines, but can also run containers and can be equally as important, orchestrated from Kubernetes. That is, using Kubernetes, I cannot just deploy containers, but I will also have the ability to deploy virtual machines. Now think about that. All right, so again, getting back on track, I have my SDDC, I have my clusters, I go into vSphere, and I say I want to enable one or more of these clusters as a supervisor cluster. In doing so, or once I've done that rather, I would then go in and I will carve out namespaces, one or more namespaces. Remember, with namespaces, what I'm doing is I have the ability to now go in and define resource allocation to the namespace. I have the ability to go in and define role-based access control and authorization, and therefore say this business unit has access to this namespace and can therefore deploy pods within this namespace. And that's all they have access to. So they have access to this one, but not to that one, right? With that, I can now turn this over to my DevOps team and they can start deploying pods. I can, of course, go in after the fact as we get more requests from different teams or for different applications and create additional namespaces. And like I did for the first few, assign the appropriate resources right? I am the IT, the vSphere guy. I'm doing all of this in vCenter, mind you, right? Assign the resources, almost as though I'm creating a resource pool and assigning a resource. Assigning the role-based access control and saying who has control over that namespace, so on and so forth. All right. Now, when we enable a cluster as a supervisor cluster, there's this notion of something called CRDs, custom resource definitions, that we leverage. What CRDs are is a way of telling the Kubernetes environment that, hey, Mr. Kubernetes, you know everything that there is to know about deploying containers as pods. Great. But guess what? You don't know squat about virtual machines. I want you to be able to deploy a virtual machine. So what I do is I create a custom resource definition, or CRD. Here we call them operators. So what you see, we have VM operator. That's a CRD. So the cluster has a CRD for VM operators. What this allows us to do is it allows the DevOps admin not just to deploy pods, but can also deploy virtual machines. Imagine a situation wherein these two pods needed a database server. And because containers are stateless, we need to store the information somewhere that's stateful. Now, I could go into vSphere, yes, and deploy a VM from a template, right? But then I have to go install the database server in it, right? Or I can deploy a template that already has the database and deploy that, but then I still potentially have to go patch it and all that stuff. What we are saying here is you can have Kubernetes deploy the VM and point it to an image for it to use to install the application as well, or that VM, all at once while it's deploying the pod, before, after, whatever the case might be. But the point is, again, it also knows about VMs, or will also know about VMs, because that feature is coming. It's not full-fledged yet, okay? And then we also have some additional CRDs for the Tanzu Kubernetes Grid, right? And the cluster APIs. What this allows us to do is to now have the DevOps team say, you know what? Though we have these pods which are running natively on vSphere, I don't want that. What I want is, or in addition to that, what I want is, I want to create my own standard Kubernetes cluster, right? So this Tanzu Kubernetes Grid will allow us to, using the cluster API, deploy a Tanzu Kubernetes cluster. That cluster will be comprised of multiple virtual machines, one of them being a master and the others being worker nodes. And now my DevOps team will use these virtual machines or this cluster and create their namespaces and deploy their pods. So going to a question that was raised about, why one versus the other, right? So over here to the left, these are my native vSphere pods running on vSphere. Over here, these pods are the ones that are running in Tanzu Kubernetes, which are running on virtual machines, as you can see here, right? Again, why? So essentially, there's a number of decision points, but one of which that's inarguable is performance, as you can imagine. If I want to give that through performance and throughput for my pods, then you want to put those pods on the hypervisor, right, directly, as opposed to putting them into a virtual machine. There's been tons of tests that have been done, even comparing this to a bare metal, and it outperformed running pods on bare metal servers. This is because of the way vSphere handles CPU scheduling. It's able to do that better than a Linux host can do it. Because in Linux, we're using CNAMEs to essentially isolate the pods or the containers. Here we're not. The other thing is security and isolation. In a standard Linux distribution, when I deploy a container, I can set that container to be a privileged container. And what that means is that container has the ability to look into other containers running on that system to see what they're doing. Here, just like with virtual machines, the fact that this virtual machine cannot see what's going on in this virtual machine and vice versa, you cannot use privileged containers. But again, going back to why I would do one versus the other, maybe my developers need to have that level of control here. We want to be able to run privileged containers. We want my containers to be able to mount the disk on the OS so that they can write directly to the disk, right? Things like that. And this is not to say I cannot use persistent storage for containers that are native. I can, but this is not a VM. This is the hypervisor. You don't have a file system there to mount natively. There's the vSAN service that you can leverage NFS to mount and multiple things. Let's not get into that. But the point is there are ways to get around that. But if I wanted to do it the standard way that people do it, then we do this. So, and alongside that question, I guess we can even feel that further as we go along in this slide, because here we start to look at, you know, how all of this comes together, right? We're looking at a standard vSphere cluster, right? The standard vSphere cluster is running the hostd process, which allows it to manage virtual machines and the overall vSphere infrastructure. When I go in and I say I want to make this a supervisor cluster, what happens behind the scenes? Well, let's take a look. One of the things that happens is we deploy per node a control plane VM. Remember the K8 master? Well, we're deploying an equivalent on each node in that cluster, so that when the DevOps admin sends his kubectl command to create a pod or whatever it is that he's attempting to do, that one of those guys will get it and process it. Okay. We also install onto each of those hosts something called a spherelet. You guys remember kubelet? The kubelet we said is kind of like the Kubernetes agent running in the Kubernetes node, right? So we essentially turn this ESXi host into, for all intents and purposes, a worker node by installing a modified version of kubelet called spherelet. So the end result is every ESXi host has a master and has a slave node. Okay. And with this, your DevOps can start deploying pods native to this environment. The pods use a component known as CRX. So just like virtual machines uses VMX to define the virtual machine, we use CRX to define your pods or your containers. But again, they're running natively on that hypervisor. Okay. Within this environment, using your cluster API commands, we can also send commands for us to create one or more Tanzu Kubernetes cluster. And remember, Tanzu Kubernetes cluster is going to deploy multiple VMs, right? One will be a master, the other ones will be worker nodes, excuse me. And that gives the DevOps team complete control over that distribution and over that deployment. Now, that deployment, of course, is running in a namespace that was defined by the IT ops team. And the namespace relegates essentially how much resources dedicated to it, who can have access to it, so on and so forth. So the IT admin still has control, if you will. It's just that if they wanted more control, right, over the underlying infrastructure, that they can build their own infrastructure, but they're building that infrastructure on yours, and you've defined as the IT admin or the VI admin what they should have and what they have access to, and who has that level of access. NSX provides all of these capabilities for vSphere with Kubernetes and other Kubernetes orchestration tool or container orchestration tools, not just vSphere with Kubernetes. It can provide IPAM. If you think about it, when we deploy these pods, right, we need to connect to them. Well, first dimension of connecting to anything is we need to know what that thing is. It has to have an identity. It has to have an IP address. The developer doesn't hard code the IP address. God, please no, let that not happen. God forbid, right? So something needs to deliver the IP address, and NSX can do that. And we will step through each one of these, and I'll show you how exactly it's done in the upcoming slides. The other thing is segmented network. We need to have isolation between our pods in some cases, and this is where we start by defining segments. And again, actually, where we start to define namespaces. And again, every namespace will get, and you'll see this in detail, an isolated segment. Namespaces by default are not allowed to communicate with one another. So not only do they have an isolated segment, they also have a firewall rule that restricts communications between namespaces, which brings us into our firewall isolation. All right. So as part of the deployment of the pods, the DevOps team can also put in network policies, which will go in and configure the firewall rules to allow pod-to-pod communication, namespace to namespace communication if we so desire that, right? Because think about it, if we're saying we want this instantaneous deployment of an application, we don't want the network to be the hinge that essentially drags us down to the bottom of the sea because the network isn't ready yet. So at the point we are deploying these things, right, let's go ahead and tell not just the cloud platform what we needed to deploy from a resource standpoint as it relates to compute, but let's also tell the networking platform what we need from a perspective of network resources and services, and have it all spun up at once. All this said, we may also need to allow ingress, traffic in, and egress, traffic out. NSX can provide load balancing and NAT services for these. Pods ran in vSphere with Kubernetes, or again, any other Kubernetes platform. And finally, visibility. I can't, for the life of me, protect or troubleshoot something that I can't see. And with NSX, I have visibility into seeing my container inventory, just like I can see VM's inventory. I can do a trace flow between my containers or VMs to containers. And you see all of this as we step through the upcoming slides. So, quick overview of the topology, right? What do we have? Well, every time you deploy a supervisor cluster, right, automatically behind the scenes, a T1 gateway is going to get created. Okay, that T1 gateway gets created, it plumbs the routing to your T0. So note the T0 has to already be there. So you would, as the NSX admin, you would have deployed your T0, you have done your BGP pairing. That needs to be done, right? Deployment of a supervisor cluster does not take care of that for you. The deployment of a supervisor cluster takes care of everything from here down. Okay, so you're gonna deploy my supervisor cluster. It creates that gateway, right? It connects it to my tier 0. It puts in a firewall, the gateway firewall, to not allow anything in. Nothing comes in by default. Okay. Then, as I create segments, or excuse me, as I create namespaces. So here I go and I create a namespace. When I create a namespace, every namespace is going to get an overlay segment created for it. As I deploy pods, those pods will get a DFW filter associated with them so that we can express firewall rules between them, right? Those, because they show up in the inventory, they can be tagged, and those tags can be used in groups to congregate my grouping, and then those groups in turn using firewall rules. When I call on, as the DevOps operator, cluster IP, service type cluster IP, right? What's going to happen is a distributed load balancer will get created to ensure east-west load balancing without unnecessary egressing of traffic outside of the host to an edge node to be load balanced, only to be returned back potentially to the same host, or worse yet, to another host, right? So running right next to that pod in kernel is a load balancer that will handle the load balancing internally for east-west, right? So for instance, we hit the web front end, the web front end needs to get to some application that's being ran by a container, right? We don't want to go all the way out and handle load balancing. The load balancing happens right there. But at the point where traffic is coming into that web front end, that will be handled here on my T1, right? My T1 will provide the layer 4 and layer 7 load balancing and NATing. So how do we create all of this stuff? Starting with IPAM. With IPAM, you go into your workload management and you say you want to configure the network when you go into define your supervisor cluster. And this is what the screenshot, this is an exact screenshot. As you do that, you're going to have to provide some CIDRs, right? So in there, you will specify, you know, the pool CIDR that you want to use. That's basically what these pods, where they will get IP addresses from. You would define for your services, that will be for your load balancer, right? So if I'm going to do distributed load balancer, where it's going to get its IPs from. and then you're going to do egress and ingress. That would be for the T1 NATing and load balancing. Okay. So, as we mentioned, NSX will also provide segmentation of the network. So if you look closely, you will see here we have illustrated a single supervisor cluster. On the supervisor cluster, we have two namespaces, finance and a marketing. Each namespace gets a segment, as you can see. These segments go up to the T1 gateway. But namespaces are isolated. There's distributed firewalls in place that allow them not to talk to one another. Okay? This is where we are talking native pods running on vSphere. Now, what if I did a Tanzu Kubernetes cluster? For my Tanzu Kubernetes cluster, we will get a T1 created for each Tanzu cluster, right? That will handle the ingress and egress for load balancing and NATing respectively. But notice it's also going to the same T0 that my supervisor cluster's T1 is going to. As far as security, again, at the T1, we're going to have a firewall rule. And as an admin, I have the ability to go in and start to define what type of traffic I want to allow in and out. I'll go to NSX and do that. Or even as the DevOps person, I can define network policies, right, to leverage some of that. In most cases, however, DevOps will be defining network policies for their pods, right? And not necessarily all the way up to the T1. That's something you want to leave for the IT admins or the security admins to handle. Right? And again, for when you create a network policy for the pods, those are being realized in NSX in the form of distributed firewall rules. But take nothing away from this, understand that by default, there's going to be isolation between your namespaces, not just because they're on different segments, but also because there are rules in place to allow nothing from one namespace to talk to something else in another namespace. If you remember, we started by saying, consider namespace as kind of a tenancy boundary, like a tenant. If this was being provided externally and I was a cloud provider, tenant 1 should not talk to tenant 2, even though they're residing on the same system, right? So it's implemented this way to enforce that level of tenancy. Then comes the load balancer. As we mentioned, it can provide ingress services. So if I go in and I define a service in Kubernetes for ingress, NSX can essentially take over and provide that ingress service on my T1. If I define a cluster IP, then it does a distributed load balancer, which is running internally in the hypervisor. So let's talk visibility. As we said, the last thing that it provides is visibility. I can't troubleshoot something and I can't protect something if I can't see what's going on. So in NSX-T 3.0, we have this new construct that's available called network topology. It wasn't there before. So if you go to network topology, you will notice you can see your network topology. Maybe not the prettiest diagram, right? But the point is you can see. So here I can see, that's my T0, right? I can see the connection between my T1 and my T0. That's the T1. It says T1 gateway. I can see that there's 16 segments here. And on these segments, I have 7 pods and 3 VMs, right? So I have instant visibility into my network topology. What is the topology that's in place for connectivity from point A to point B? Now, this, of course, is not showing me flow information. It's not showing me where things are breaking down, if they are indeed breaking down, right? The next thing, though, is, just a moment, let's erase that up, is inventory visibility. We've always had the ability to go to inventory and then virtual machines to see what the virtual machines are. Now, look, we have the ability to go to containers and see what your containers are. So here I am as an NSX admin. I go to inventory containers. I can see my containers. I can see how many nodes, what namespaces, the pods, the services, the networking elements that are delivered for those containers. You can see all the details, right, about that cluster. And then, as I mentioned, you also have the ability to use traceroute to see the path and to see potentially where things are breaking down. So in this example, this screenshot, you notice where we go in and we put in the source for my hello world container and this nginx goodbye. And we say, let's go ahead and run a trace, right? And you can see it shows us graphically and also step by step, right? The flow, leaving the container, going to the container node, making its way up to the segment, so on and so forth. And of course, if there was any failure along the way, you would see it in the list and you can click on it. Let's assume there's a distributed firewall rule that was blocking it. You would see that there's a DFW rule that blocked that traffic and you see the rule ID. So this allows me to go and troubleshoot. In this case though, you know that the traffic was delivered. All right, so in a nutshell, again, NSX is delivered from the ground up to provide networking and security services for all workloads, including containers, right? Our focus with this conversation that we've just had in the presentation has been more so around vSphere with Kubernetes, but again, remember that this can be leveraged across the board for other container orchestration tools using the NCP.